Okay, this video is going to be on the power rule with exponents, and I'm actually going to do it slightly differently than I did it in class because I feel like a lot of us are missing the power of the chain rule, so I'm going to start spiraling in what the chain rule really is. Okay, so if we have our power rule, it means we have some variable to a certain power. That is what tells me that we need to use the power rule. So I want to see something that looks like x to the n. And if we see this, it means the power rule. And all that happens is we take our exponent and we bring it to the front. Bring our exponent to the front. And we subtract 1 from our exponent. And then the piece I'm adding is, to spiral in the chain rule, is that's also going to be times the derivative of x. Times the derivative of this, this piece right here. So, now let's do some examples. We have d over dx, the derivative of x cubed. Well, I see that we have a cubed right there. We have x to the n, and our n in this case is 3. I'll even write this, n equals 3. So now we're just going to substitute stuff in. We have 3 times x to the 3 minus 1 times dx. Well, that's just 3x, 3 minus 1 is 2, and the derivative of x is just 1. So that dx goes away. Second example, we have x to the 1/3. Again, this looks very classic power rule. We have n equals 1/3. So that just means we're going to have a coefficient of 1/3, x to the 1/3 minus 1 times dx. And then we'll just simplify this out. We get 1/3 x. 1/3 minus 1 is negative 2/3 dx. Or I'm sorry, I don't want to write the dx anymore because the derivative of x is just 1, so that goes away. We can simplify it out. And now let's just make this look prettier. We get, if we have a negative exponent, we can make it positive by just moving it to the denominator. So we have 1 over 3 x to the 2/3. And there's our derivative of x to the 1/3. Next example, this is where we start getting a little fancier with it. We have the square root of x, which we just need to turn into a power. So if we take our square root of x and we say, well, that's just x to the 1/2, now we get that our n is 1/2. So we bring our exponent to the front. We get 1/2 times x to the 1/2 minus 1 times dx. Then we get 1 over 2 x to the negative 1/2 times dx, which is just 1. And then again, make our exponent positive, 1 over 2 x to the positive 1/2. If you wanted to, you could turn that back into a root, but I'm just going to leave it as an exponent. Next example, now we have 1 over x cubed. Well, this sort of looks like our power rule, except our variable's on the bottom. But we can say, just how we've been taking our negative exponents and making them positive by moving it to the denominator, we can do that rule in reverse and take our exponent and make it negative so that we now have it, our x to the n is on the numerator. And now we can just write n equals -3. We bring that out, -3 x to the -3 minus 1 times dx. That's just -3 x to the -4. The derivative of x is 1. Make our thing positive again, -3 over x to the -4th. I'm sorry, to the +4. There's that example. Last example I'm going to do, we have 1 over the square root of x. Again, we want to make this look like x to the n. So I'm going to first take this 1 over square root of x, and I'm going to say, well, that's the same as 1 over x to the 1/2. And now we'll use our exponent rules to say that this is x to the -1/2. N equals -1/2. So we have -1 over 2 times x to the -1 over 2 minus 1 times dx. That gives us -1/2 x, or I can drop the colors here, -1/2 x to the -3/2 dx is just 1. Make our exponent positive, 1 over 2 x to the 3/2. And there's the power rule. That's pretty much everything we need to know about the power rule. I actually will do one more example that I think will be helpful now that I'm thinking about it. If we were to take the derivative of, let's say, x to the 3/2 minus 2 over x, 2 over the square root of x. We're just going to look at this piece by piece. So this is still our power rule, but I'm just going to have to look at each piece individually. I'm going to start with my left piece, x to the 3/2. Well, my n here is 3/2. And we can start doing it. So I'm going to get 3 over 2 x to the 3 over 2 minus 1 times dx minus, and now we'll look at our other piece, and this is, well, I already wrote the minus, but so I'll just do this. 2 over the square root of x, which if we go through the steps of making that look nicer, we get 2x to the -1/2. N equals -1/2. Let me choose a different color. Let me choose red for this one. N equals -1/2. And so now we have minus 2 times -1/2 x to the -1/2 minus 1 dx. Zoom out a little bit so you can see it all. And then I'm just going to go down, start simplifying stuff. We get 3 over 2 x to the 1/2 dx is still just 1, plus 2 times -1/2 is positive 1, x to the -3 over 2 dx is still just 1. Simplify further, 3/2 x to the 1/2 plus 1 over x to the 3/2. And there's our derivative if we were looking at multiple pieces. We're just going to split it up. All right, hope this helps.